Hello everyone, welcome to this live session. We will talk about Maestro 3D software for orthodontic projects. I would like to start with a brief introduction of the software itself. So after an overview of the software, we'll share with you a subset of the specification sheet. We will go through the different available modules and at the end we will design together a sample case. The software is based on a totally proprietary technology. It's modular and the three main modules are Ortho Studio for orthodontic jobs, dental restoration and Smile Creator. During this live session, we will focus on the first one, the Ortho Studio for orthodontic projects. As you can see, the input and output files are in open file formats as STL, OBJ, PLY. It means that the system is open, so you can import surfaces acquired by every kind of scanner and you can export the output files for producing them to every kind of production machine. It's possible to record a video during your design. This video can be added to the final report. The software is compatible with 3D mouse and touchscreen, and the final PDF report, let me say, that is really an exhaustive and complete report, and it's perfect for sharing all the details, all the measures, all the analysis you have performed during your job, and all these data can be shared perfectly with the different stakeholders of this specific project. Online it's possible to find several video tutorials, also a wiki user manual is available, and the user interface is also available in multiple languages, starting from Italian, English, Spanish, and so on. Last but not the least, the annual fee is not required, so your license is permanent and you are not asked to pay an annual fee. Let's go through the different available modules of the Ortho Studio. The first is called Orthodontic Basic module, and it allows to manage clinics, doctors, patients, and cases through a database. You can create the virtual basis, you can perform occlusal inspection analysis. Thanks to the 2 and 3 dimensional sections, you have always the complete control of what you are doing during your project, and you can take measures on teeth and full arches. This module is the basic one and it's required in order to use the other modules. The second one is called Virtual Setup module, and it allows to move the teeth for both the arches. And let's say this is the module for designing the future patient's mouth. So you can evaluate always distances, contacts, and intersections. You can customize and let's say you can create and customize attachments and label. And also two very helpful features are available as the teeth extraction and the interproximal reduction. Thanks to the Model Builder module, it's possible to create the set of 3D models needed for the whole orthodontic treatment. These surfaces can be exported in open file format, as I told you before, and the models are optimized for 3D printing. The user can decide, can set different parameters, and one of them, very important, is the number of the needed transition models. The brackets placement module allows to place the brackets on the teeth automatically or manually. This placement can be done following different placement techniques, step, rhythm, and so on. And also several types of tray for the transfer of the brackets in the mouth of the patient are available. Then the Virtual Clear Aligner module allows to design and construct the clear aligners in a virtual way. So you can draw the aligner shape, setting the needed value of thickness. It's also possible to set a variable thickness for each aligner, and it's possible to simulate the thermoforming process. On the right side of the screen, you can see a sample picture of the virtual clear design. At the same step, you can make bracket transfer trays for bracket placement in different ways. The default one, like this, as you can see in the picture, or if you have added jigs, you can export a bracket transfer tray for bracket placement, let's say with jigs, and also you can export this transfer tray with windows. At the same step, at the same module, sorry, you can make the guide for etching the attachment placement. These are the modules of the Ortho Studio 1. I would like to share with you further info that from my point of view are very, very important. The first is that it's possible to combine the real roots coming from a CBCT device. So you know that it's not possible to acquire the shape of the real roots working with a light or laser scanner. So it's necessary to work with a CBCT device. But you can import the acquired surfaces and combine the scanned crowns with the real roots. When it's possible, when they are available, it's very important to work with the real roots in order to determine the real axis of the teeth. Then an info related to the final PDF report is possible to embed inside the PDF report the 3D models of the case. So it's very helpful, this function, for sharing all the details with the different stakeholders of this single project. I think that now we can start with the real case. At the end of the presentation, I'm available, of course, for answering to all your questions. Okay, let's start. I'm opening the Dental Studio management tool. As you can see, I'm working with a demo version, so I have to skip the job definition, the job order process, and also how to import the STL files, but don't mind about it, because as I told you, several video tutorials are available online. So double clicking on a listed project and a preview of the surfaces is displayed. Pressing next, you are confirming that you want to work on this project, and the design software opens automatically. This is the user interface of the design software. On the bottom left side of the screen, you can see some details related to the job order, so the name of the clinic, the doctor, and so on. Here you can play with the visualization options, deciding what you want to see on the screen. You can change the view here, or you can decide which arc you want to see on the monitor. And also on this toolbar you have other options related to the visualization. So we can start. The first step is related to the reference coordinate system. As I told you before, the system is open, so you can import data from every kind of scanner. So it's necessary to put the objects in the correct system of reference that the software requires. For doing that, we have a tool called Change Local Origo. Here you are asked to draw a line by picking 3 points or picking more than 3 points. The target of this line is to define the position of the occlusal plane. The picked points can be moved so you can adjust what you have already done. For confirming, just press next. And the second step of this procedure, you can set the position of the models more precisely. So three different directions are available as reference: the occlusal, the transversal, and the sagittal one, and you can rotate this manipulator in order to get the best positioning for your models. For jumping back to the default positions, so the position that you have defined, just press reset. Yes, I want to save. At the end of each tool, the software asks you if you wanted to save what you have done. That's perfect. Okay, once at the right position, I can change the virtual articulation thanks to this software, this tool. I can decide which arc will be involved, in this case the upper jaw, by pressing the Shift keyboard mouse and the left mouse button, and I can move and pan my arc. By pressing the Control keyboard button, I can rotate it. What is important is that we have always the complete control of the distances and on the intersections. I can change the scale of my color map in order to have always the complete control. Go. Now I can create the virtual basis. It's so easy. The software is asking to me to define the trimming line in this way, just picking points. Double click on the left mouse button for adding a new point. I'm doing it so fast. Okay, and double. You can add the control point wherever you want, and you can move the line thanks to these control points in order to obtain the wished trimming line. Before going ahead, I have to move this blue point for confirming which part of the model I want to leave for creating my final 3D model. I'm asked to repeat the same procedure for the other arc. Okay, let's go. Again, another point. Then I would like to add the new control points here. There we are. Okay, this is my mistake. Just moving this point, I can obtain a closed line as I want. I move the blue point as I did before for confirming which part I want to leave. Now I can design my virtual basis. Thanks to the directions defined by these arrows, I can design pressing Shift button on your keyboard. I can move along this direction my basis. As you can see, I have several possibilities. I can add, enlarge the distances between the two bases, everything, and can also work and design point by point. Let me go ahead, and that's it. This is my model. Next, for confirming, the software is saving. I would like to point out that I'm not designing this project from, let's say, a medical point of view, but just for showing you what is possible to do with this software. So I'm not a doctor, I'm not a dentist, but I just would like to show you how to do and what is possible to do. Then it's up to you to apply your theories, to apply your processes and so on in order to obtain the perfect result from the medical point of view. So once defined the basis, I can also add the labels. It's very easy, just pressing plus and double click on the model. My label is placed, then I can change the text. Shining 3D. One click here and the text has been updated. Thanks to this manipulator, I can rotate, move and enlarge my text, that my label that can be negative or positive. I can set the thickness and so on. Let's go. So I set the right position of my models. I set the right articulation. I create and I've made the virtual basis and I added a label. I'm ready now for starting the analysis and measures step. So the second tab, this one, is called Analysis and Measures, and different tools are available in order to perform this analysis. So the first is for performing occlusion inspection. As you can see here, I can change, as I showed you before, I can change the scale and the color in this way, and that's it. The second is related to the sections. It's possible to define several and different sections. First of all, it's necessary to define and to set which is the plane that will be involved for getting these sections. Once set the plane, I can move it by this cursor, and on the right side of the screen I have the wished section. I can take measurements like this and I can save this section. Also I can rename the section. No limit regarding the number of added sections. Okay, let's go ahead. Now we have a very important step. So I'm asked to take mesial and distal measurements. I will apply all my all this project will be let's say applied on just one arc, because I wanted to save time. I don't want to waste your time, so I will apply just on the inferior. So here I'm asked to pick distal and mesial points for each element. Once pick the points, here I can change the number of the element. That obviously depends on the patient's mouth. Let me do it fast. I don't mind if I'm doing some mistake. This step is mandatory and it's required because thanks to this step the software is able to perform the tooth segmentation. That will be the next step. this and this. I'm doing very fast, but please take your time for defining the best points, because these will affect all your projects. But this is just a sample case for showing you what is possible to do and how it's possible to do. This and this, and the last one. Okay, done. Once done, I can fix some mistakes, as I did in this way, and so on. I would like to share with you a picture for showing you how to recognize a wrong and a correct way to take these measures. This is wrong, this is correct. You have always the reference of the lingual direction, that is actually is this the direction of this blue arrow. Okay, let me go ahead. Proceed with tooth segmentation. Yes. The software now is performing the tooth segmentation. It's also possible to perform the Bolton analysis. According to Bolton, there exists a ratio between the mesial distal width of maxillary and mandibular teeth. This analysis helps in determining tooth size discrepancy. And actually, for this project, the Bolton analysis will not be available because I'm working just on one arc. Wow, pay attention when you move your mouse, don't do it so fast as I'm doing. The software is asking to me now to check if the detected trimming lines are okay or not, and I have the possibility to fix eventual mistakes in this way, by moving the control points or by adding new control points in this way. I have to check element by element. It's okay, I'm doing very fast as I told you before, so please take your time when you wanted to work on this project. Okay, this is wrong. This is because my mesodistal measure was taken wrongly, but I can repair it just moving the control points, as I'm doing now. So very easy. If the line is totally wrong, so and it takes a lot of time for fixing the mistakes, you can delete the line, and picking the points, you can start from the beginning designing the wished line. That's it. Let's check this one. Next. Okay, I'm sure this I will have some issues here. This is an element that I will extract, because it's also possible, as I told you before, to extract teeth. Next, try to fix this, just deleting one point. For deleting one point, just double click on the left mouse button, and the last one. Here we are. Go. Yes, I want to save it. The software is performing the analysis of the trimming lines previously detected or fixed manually by me, and the software will join them based on this value. This value is the interproximal distance, and I can set it moving this cursor. So, starting from this value, the software will decide if the trimming lines can be joined or not. I will not change this value because this is just a sample, and I can go. Okay, I think that few seconds and there we are. The software is performing several computations now. Yes, I want to save. And the next step is related to the definition of the local tooth axis. It's exactly the step where you can import the real roots acquired by a CBCT scanner. I would like to share with you this picture that is related to the final result of the merging between the real roots acquired by a CBCT device and the acquired elements via laser or a light scanner. Okay, I'm asked, as I told you, to define the local axis. How to do it? In this way, just double click on an element and the manipulator is displayed. I can move this manipulator and my movements affects the position of the roots of that single root, and but I can also work directly on the different point of view thanks to these arrows. Okay, I can perform this evaluation, this analysis, element by element. Let me go ahead. Yes, I want to save. And now I'm ready for starting the virtual setup process. So now I can open the virtual setup tab and start my designing. And sorry, start designing the patient's mouth. Here, virtual setup. So at this step it's possible to move and rotate the teeth in order to get the expected final position. In this way, so I have first of all to highlight the elements that will be imported, double click with the left mouse button, and if I wanted to work just on one element, I can do it manually by pressing the shift keyboard button and the left mouse button. I can move it wherever I want, and pressing the control keyboard button I can rotate it. I can add some constraints that get it easier. Just a sample, if I add a constraint related to the rotation, the element can rotate just along this direction. If I set the transversal direction, just along this direction. It's possible to work with different layers, so means that you can define, move and rotate some groups of teeth in this way by pressing Ctrl and double click on the left mouse button. You can select more elements and your design will affect all the selected elements. Or I can ask the software to highlight automatically just the anterior in this way, or just the posterior. Very easy. Another thing that is possible to do that gets this software so easy, you can move and rotate your elements thanks to the different parameters. So, for example, the tip by this cursor, you have the possibility to rotate, having more control than moving it manually. Or you can press the plus or the minus button for having a very small movements. Another very important feature is related to the fact that it's possible to divide the screen in more parts in order to have a different point of view at the same time. So if I wanted to work on this element, let me select them and move in this way. As you can see, my movements affects obviously the two different points of view. So I have the complete control. I can also divide the screen in four different point of view, with four different point of view. Okay. Oh, very important. I told you that I wanted to extract this element. So if you wanted to extract an element, just select that element, right mouse button and press extraction. Perfect. Another very important feature that I mentioned during my presentation is related to the IPR, the interproximal reduction that is used when teeth are overcrowded. And it involves the dentist stripping away a portion tooth in order to create space. But this reduction is applied to the teeth in their initial position, because the cut can be done only before putting the clear aligners. So if I press this, the software informs me, okay, do you want to restore temporarily the position, the original position of this tooth, yes or not? Okay. Okay, we have here always the possibility to we have the color map for checking the distances and so on. And I think that for this step we have the IPR. I think that we are. Yes, I want to save. Oh, I didn't tell you that obviously it's possible to add one or more attachments for each tooth, and deciding also its shape, thickness and so on. And attachments are very important because they act like anchors for the clear aligner. But the time is running and I have a lot of things to cover, so perhaps in the next webinar, in the next remote session, I can show you deeper some feature. Okay, then here I can add brackets if I want, or if I want to skip, if I want to create clear aligners, the next step is related to the creation of the 3D models for the orthodontic treatment. So here I have a comparison between the original patient's mouth and the final patient's mouth. I can decide the different layer, and here I can set the number of the models, but also the different constraints. So the max value of rotation of tip for each layer. If I increase these values, as you can see here, the number of models decrease. Let me do something that has no sense in general, just for having a few models. But let's say you can create and add a new configuration depending on what is possible to do with that clear aligner. So for this case, I will have 4 models, transition models. I can set the weeks per aligner and have the final duration of the treatment, in this case 2 months. Yes, I want to save. I'm going now to show you how to export the models and the clear aligners. The software is saving. Here we are. This is the button for exporting the 3D models. I can export the clear aligner, I can export the brackets template or the transition models and different options. Let's start with the transition models. Okay, I can decide the file type opens. These are open, as I showed before. Next, I can decide where I want to save them. And that's it. I've just exported the 3 models. Now I wanted to export the clear aligners that obviously the software is asking to me to define the clear aligners because I didn't. For defining clear aligners, this is the tool, clear aligner. I have the insertion direction and I have a color map that shows the undercut surfaces. So here I'm asked to draw the line for the clear aligner. As I told you, I'm doing faster. Please take your time when you work on a real case and don't mind because no one will put my aligner into its mouth. So it's just a sample for showing you what is possible to do, as I told you before. Okay, the tool is exactly the same. We work with okay, the line is closed. Then if I want, I can add control points for having the complete control of what I wanted to obtain at the end, also here, and so on. Let's go. I will apply the aligners to all transitions models. So now the software is asked to create 5 clear aligners. As before, I have to move the blue point for confirming which part will be involved, and next. Okay, the software is creating. Meantime, I would like to show you some pictures. This is related to sorry. This is related to the aligner brackets with windows or without, and this is in case you have added jig. Okay, this is my result, and now I can export the aligners. I will export on the same exactly on the same folder, to the same folder, and that's it. Okay, this is the folder. So I have the initial positioning. This is the first aligner. Then I have the different models, another aligner, lower jaw, and so on. This is a transition model, the number 4. Okay, last step, I can export my PDF report. With the name of the company, I can set different values for these fields, Sudanna Grafica, the ID of the customer, and so on. Next, I will save it on the same there we are. There we are. So I have all the pictures related to the models, the measures I've taken, the different values of the movements for designing the patient's mouth, the extraction of one element, and all the info that I need. At the end, oops, sorry, I have also the possibility to see, I have to enable to see the 3D model. Not just one, I have different 3D models, and this is 3D models into the PDF report. So it's perfect for sharing, as I told you, details and analysis you have performed with the different stakeholders. And that's it. Thanks a lot for your attention and for your time. And now Filippo, my colleague Filippo, is going to show you how to print out these transition models and the aligners with the AccuFab 1 3D printer provided by Shining 3D.
Thank you, Simone. Thanks a lot. Yes, now in a few minutes I will show you how we can create the aligner. So these are the files that Simone just created. I'm importing with drag and drop the file in the 3D DLP software. Okay, done. Now I can ask the software to compose the model in the right way. Thanks to the intelligent composition button, it's possible to place the model in the right position, in the best position on the printer platform. Sorry. Okay, I think it's correct. As you saw, I reverted the model in order to have the supports on the occlusal surface, not in contact with the teeth, I mean. I'm increasing the height of the pins in order to remove in an easily way the pins when printed the models. Okay, that's it, perfect. As you can see, the software automatically create the support in the correct way in order to print this material. Okay, and now we can create the slice. We can start with the printing phase. Perfect. And okay, I printed the model this afternoon, and this is the result after the printing phase. I'm removing the platform from the printer here, and as you can see, here we have the byte, the transition byte printed. Thank you for your time, thank you for your attention, and now if you have any question, please feel free to write in the chat your question. Me, Simone, Riccardo and Rita are completely at your disposal. Thank you.
Okay, thank you, Simone. Thank you, Filippo, for the extraordinary presentation. We do hope that you enjoyed this webinar, that you enjoyed the overview on the extremely performing software Maestro 3D. Let me please also sincerely thank you, the team of Maestro 3D, who constantly do a really remarkable job in the development, in the support, in everything regarding the like I said, the development of this product. So thank you once again to Maestro 3D team. As always, there is still some time for the Q&A session. So we are here to answer to your questions, and if you want to rewatch the video, you will have the chance to see that on our YouTube channel, and you will also have the chance, as always, to contact us via emails or here on Facebook directly. So I can see some questions. Nice presentation, really, thank you very much. I want to ask about the material used for the printing. Okay, regarding the material, just consider that we are testing some prototypes, we are making some tests with the materials, so it is not something that we can already recommend. The purpose of the video was to show the workflow and to see what you are able to do. Then for further details regarding the material, we can contact you in the following days and weeks to provide more specific information about that. Shining and Maestro, two great companies. Thank you very much, Jean-Marc Svets. Thank you very much. Umesh, you still can't hear me. I would like to know from you people if you can still hear me, because I see the latest comment from Mr. Umesh that maybe he still cannot hear me. So maybe okay, perfect. So last question was always regarding the materials. I hope that you heard the answer. In case you didn't, I'm just repeating it again, sorry. What I meant is that the purpose of the video was to giving an overview on the workflow from the design on Maestro 3D to the 3D printing. The material we used is a material that we are testing now. It's not something that we can already provide, but we will be more precise in providing information regarding materials in the following weeks. I hope that you have been able to hear my answer. In case you didn't, I will contact you separately and after the call to provide all the information that you need, for sure. I will text now in the comment once again the email address you can send your emails to in order to receive technical information and any type of support from our team. My pleasure, Ramesh. Thank you very much, and thank you. A special thanks to you that you're always so proactive in our webinars, and we truly appreciate your participations. Thank you very much. Of course, we can get in touch with you, Mr. Ali, to make more tests and to have to share the opinion and feedback regarding the test of the materials. No problem. Okay. Perfect. So if there are no other questions, I think that we can finish here. And like I said, let me please repeat it once again. If you lost the connection before, we are always available on the email address that I have texted in the comments. You can also send us private messages here on Facebook. Our team, both from sales department and technical support department, is always available to provide all the information that you need. So thank you once again for attending the webinar. Thank you once again for your attention, for your questions. We hope to see you all in the next webinar next week. Thank you very much.
Thank you. Thank you. Bye-bye.
Thank you. Bye. Thank you.
Thank you. Bye bye.